Welcome to aminacademy.com. In chemistry, let us discuss about intermolecular forces. Particles attract each other, so it takes energy to overcome the forces holding them together. It is taken high energy to separate the particles of a substance. Then it takes high energy to cause that substances to go from the liquid to gaseous state. The boiling point of a substance is a good measure of strength of the forces that hold the particles together. Melting point also relates to attractive forces between particles. Most covalent compounds melt at lower temperature than ionic compounds. In ionic substances generally have much higher forces of attraction than covalent substances. Recall that ionic substances are made up of the separate ions. Each ion is attracted to all ions of opposite charge. For small ions, this attraction holds the ion tightly in a crystalline lattice that can be disrupted only by heating the crystal at very high temperature. The strength of ionic forces depends on the size of the ions and the amount of charge. Ionic compounds with small ions have high melting points. If the ions are larger, then the distance between them are larger and the force are weaker. This effect helps explain why potassium chloride, that is KCl, melts at a lower temperature than sodium chloride, NaCl. Now compare ions and differ by the amounts of charge they have. If the ions have larger charges, then the ionic force is larger than the ionic forces of ions with smaller charges. This effect explains why calcium fluoride, that is CaF2, melts at a higher temperature than NaCl. Now, let us discuss further about the forces also exist between the molecules themselves, and there are collectively referred to as intermolecular forces. Intermolecular forces are mainly responsible for the typical characteristics of the substance. Intermolecular forces are responsible for the condensed state of matter. The particles making up solids and liquids are held together by intermolecular forces, and these forces affect a number of physical properties of matter in these two states. Here, this is intermolecular attraction, this intramolecular attraction. Means here HCl, together HCl, intermolecular attraction. Here H and Cl itself, the attraction is intramolecular attraction. Types of intermolecular forces. An intermolecular force is an attractive force that arises between the positive components or protons of a molecule and the negative components, that is electron, of another molecule. Various physical and chemical properties of substances are dependent on this force. The boiling point of a substance is proportional to the strength of its intermolecular forces. The stronger the intermolecular forces, the highest the boiling point. By comparing the boiling points of different substances, we can compare the strength of their intermolecular forces. This is because the heat absorbed by the substance and its boiling point is used to break these intermolecular forces and to convert the liquid into vapor. Now we will discuss some type of intermolecular forces. Dipole-dipole interaction. Dipole-dipole interaction are attractive forces among polar molecules. Polar molecules have permanent dipoles that are formed due to differences in the electromagnetic of the atoms that are associated with a covalent bond. The partially positive portion of one molecule is attracted to the partially negative portion of another molecule. Let us do some example for dipole-dipole interaction occur in HCl molecules. Chlorine is comparatively more electronegative than hydrogen, and it therefore acquires a partial negative charge, whereas hydrogen acquires a partial positive charge, the dipole-dipole interaction then takes place between HCl molecules. Here, dipole-dipole forces, for example, here. Next, ion-dipole interaction. These interactions are similar to dipole-dipole interaction except for the fact that they arise between ions and polar molecules. Example, when NaCl is mixed with water in a beaker, the polar H2O molecules are attracted to the sodium and chloride ions in the beaker. The strength of the interaction depends on the magnitude of the dipole moment, size of the polar molecule, the size of the charge of an ion. Next one, ion-induced dipole interaction. This type of interaction in non-polar molecules is polarized by an ion placed near it. The non-polar molecules, upon obtaining a charge, behaves as induced dipoles. This interaction between an ion and an induced dipole is known as ion-induced dipole interaction. Next one, dipole-induced dipole interaction. These interactions are similar to ion-induced dipole interaction. However, the differentiating factor is that non-polar molecules are transformed into induced dipoles due to the presence of polar molecules nearby. Dispersion forces or London forces. It operates of a short distances and it is the weakest force. This kind of force arises due to the movement of electrons, thus creating temporary positive and negative charges regions. This is a London dispersion forces happens here. Now let us do some example questions and answer. What is the effect of intermolecular forces on boiling point? The strength of intermolecular forces and the effect of boiling point. Ionic is greater, next is non-ionic, next is dispersion, next dipole, then hydrogen bonding. This highest is the ionic, second is non-ionic, dispersion, third is dipole, and fourth is hydrogen bonding. Now, what is the van der Waals force? The relatively weak and attractive forces acting on neutral atoms and molecules as a result of the electric polarization induced in each particles by the presence of other particles. Hydrogen bonding, dispersion forces, the dipole-dipole interaction are all examples of the van der Waals forces. The van der Waals force is the relatively weak attractive forces attracting on neutral atoms and molecules as a result of the electric polarization induced in each particles by the presence of their particles. Another particles. Here atom 1 here, this atom 2 attraction forces. Step 2 is atoms are polarized and attract one another. First here attracting, then atom is polarized and attracted. Characteristics of van der Waals forces. Covalent bonds and ionic bonds are significantly stronger than van der Waals forces. These forces are additive in nature. They are made up of the several individual interactions. These forces cannot be saturated. No directional characteristics can be attributed to these forces. They are not dependent on temperature except dipole-dipole interactions. Van der Waals forces are short-range forces. Their magnitude is high when the atoms molecules in question are close to each other. Here, for covalent substances, forces that act between molecules are called intermolecular forces. We discussed. Now, also, we discussed about different types of bonds and its nature and interaction forces between them. We discussed. Here, hydrogen bonding explains water's unique properties. That means hydrogen bonds. The energy of hydrogen bond is lower than that of normal chemical bonds, but can be stronger than that of other intermolecular forces. Hydrogen bonding can account for many properties. Water has unique properties. These unique properties are the result of hydrogen bonding. Water is different from most other covalent compounds because of how much it can participate in strong hydrogen bonding. In water, two hydrogen atoms are bonded to oxygen by polar covalent bonds. Each hydrogen atoms can form hydrogen bonding bonds with neighboring molecules because of the water molecules' ability to form multiple hydrogen bonds at once. The intermolecular forces in water are strong. Another different characteristics of water result from hydrogen bonding at the shape of your water molecules. Unlike most solids which are denser than their liquids, solid water is less denser than liquid water. That means ice is less denser than water and floats in the liquid water. That is, ice floats in the liquid water because of these forces. The angle between the two H atoms in water is 104.5. This angle is very close to the tetrahedral angle of 109.5. So far, we have done forces, intermolecular forces detailing. We have done. Please subscribe our YouTube channel.